Okay, I've moved to the floor for this activity. You can see I'm going to be using the Connect Coding and Robotics Learner Book for grade 1, and that's the CAPS Coding and Robotics curriculum. There's the little blue bot, and I've also got a floor mat. And the floor mat is one provided by TTS, the company that makes the blue bot robot, but it's very easy to make your own. Basically, each of these squares are 15 centimeters by 15 centimeters. You can see that's roughly the size of the blue bot, and it's how far it moves whenever we click forward and back. So what I'm going to do is I'm going to take an activity and a concept from the curriculum. I'm going to then show you how we've done it in the textbook. It's a Scratch junior activity, so an online coding activity that the learner would generally do using a laptop or a tablet. And I'm going to show you how we can translate that into a physical robotics activity using the Bluebot. So if you want to look at the curriculum doc, it's on page 43, week 5, and it's, I'm going to read it to you quickly. It's the coding and algorithm concept which has been covered is block movement and turning, and you need to construct a program using movement blocks. The example given in the curriculum doc is learners complete a basic code sequence activity on an online application. The activity needs to increase in difficulty from a minimum of 3 to maximum of 10. The basic number of instructional blocks used should start with a minimum of 1 and then progress to 4. The activity must include forward, back, right blocks. Okay, and then in the book, it's activity number 7 that we're going to reference. So you can see that's activity number 7, and it's an activity where we make a sprite move in Scratch Junior. The sprite moves 3 steps to the right and then 7 steps to the left. Okay, so sorry, I've just shown you that there quickly. And what we're going to do with the Bluebot is we're going to use it to show learners the basics of coding sequences and algorithms by giving step-by-step instructions to the Bluebot. So as I mentioned, we've got the Bluebot, we've got the mat, and we're going to place the Bluebot on the left side of the mat. So starting block A1. Just going to turn it on quick. There we go. Hello, Bluebot, you noisy thing. And then you're going to explain to the learners that each button press will make the Bluebot move 1 step in the indicated direction. So if I click 1 on there, it's going to go forward 1. Click 1 on the back button, it's going to go back 1. And then I'm going to say to the learners, how would they plan to move the Bluebot 3 steps forward? And this plan that they're putting together is their algorithm. Once they've made the plans, then ask the learners to input the instructions into the Bluebot using the forward buttons. And just remember, you need to clear all the previous instructions from the Bluebot, otherwise it will actually run through everything in its memory, sometimes to hilarious effect. Okay, so the learners have made their plan to move the Bluebot 3 steps forward, and you ask them to input that in. So I'm going to do forward 1, 2, 3. Okay, and then after the Bluebot has been programmed to move 3 steps forward, we're going to ask the learners to add to the algorithm to move the Bluebot 4 steps to the right. So if I'm looking at this map here, 1, 2, 3, 1, 2, 3, 4. Ideally, we get the Bluebot to end up on the beach over here. So the learners have to then input the next sequence into the Bluebot. So I'm going to then turn it right. 1, I've turned it right. And then move it forward. Obviously now it's facing right. 4. 1, 2, 3, and 4. Okay, so the learners just need to then test their program, and to test it they press go on top of the Bluebot, and it will then run through the sequence of commands that it's been given by the learners. If it doesn't go where we expect it to go, then obviously there's been an error with their program, and that's when we get to introduce the learners to debugging. They need to then work out where the problem was and fix it and try again. Okay, so let's just see if I've done it right. Go. Move forward 3, that's 2, 3, turn right please, and go forward 4. 1, 2, 3, and 4, yay! Okay, so this obviously worked. Very simple activity, but you can picture having all the learners around the mat, taking turns to input the algorithm that they've planned, and then obviously fixing it, perhaps even collaboratively, any errors that they may encounter. And this activity aims to introduce both the concept of sequences and then algorithms in a very hands-on and engaging way, while also promoting problem-solving skills. And that's obviously if there are any issues that the learners need to debug. Okay, great. Finished with this activity, and the next one I'll look at will be another activity from the Cambridge Connect book.